some bug bounty events, bug bounty live hacking events. I have also won the recent bug bounty live hacking event. That was the live hacking event that was done by Positive Hacks, which was called Hacks, and we hacked Telegram, we hacked Wildberries, we also hacked tm.ru, which is a Russian bank. And so I have also won this live hacking event, the three prizes. And I have done some other researches. So far I have more than 1,500 vulnerabilities found overall. And I also have found vulnerabilities on more than 1,000 companies approximately. So between these companies, we speak about lots of different companies such as Facebook, Google, Microsoft, American companies, Russian companies, European companies, and all kinds of companies. So today we are going to see what are some significant bugs that I have found recently on big companies. The main problem that we have nowadays is that some hackers find some really cool bugs, but the problem is that they don't think too much out of the box to find very harmful bugs, because they just stick to what they learned, such as you have SQL injections, you have to stick to SQL injections, or you know, for example, some kind of specific CVE, so they are going to stick to that specific CVE. But the hacker has to think out of the box, and he should try to find some new techniques which he can use to find more vulnerabilities along the way. So I hope you're ready for the talk, and let's go. So the first vulnerability we are going to explore is a vulnerability I have found on a login endpoint, where I could bypass the login endpoint by using some special So an endpoint being behind login redirected to SSO unless you added authorization bearer null. So suddenly the server assumed that there was I was authorized and skipped the login flow entirely. This was a logic flow in auth validation where a null token passed checks. So why did this actually happen, and what I initially tried? What I initially tried is accessing a protected admin endpoint, and obviously the server would say, no, you can't access that specific endpoint because you don't have any valid login authorization token. And so I always got redirected to the login page. So obviously from there you can try a few different login bypasses, which might be some SQL injection login bypasses or some other kind of bypasses. But what I have tried is testing with authorization bearer null, like you can see here in the header, and the application responded with a 200 OK instead of redirecting. So this was a straightaway bug that granted me access to a very specific endpoint which was protected by authentication, and that application failed to protect its users by not validating what is actually being sent in the GWT. So in this case, there was two specific things that were happening. First of all, if you send a valid GWT token in the header, the application will let you in. But if you send something that is not valid, it will not let you in. However, once I sent the bearer token null, just like that, it actually granted me access to the application and let me in. So you can, of course, use Burp Suite to send a payload that is very straight, and you also, we also gained full access to the application. Then what we can do is using setup match and replace rule inside Burp Suite to actually keep sending the bearer token null to the server as soon as we browse it, so it gives us access to all the pages. So behind the token trick, the application uses bearer token to validate access, but fails to verify whether the token is valid or even non-null. So why the null token worked? Because some middleware treats the presence of an authorization header as a green flag without checking its value. In this case, a null token wasn't parsed or rejected, it just passed through. So all the application did is checking if a bearer token was sent, then it checked if the bearer token was not valid, then it didn't grant authorization. But as we sent a null token, it passed the check for the application and it granted us access to the specific endpoint. So this issue often lives in custom built-in authorization filters because it's way uncommon to find this type of bugs on way known softwares. But sometimes developers make mistakes because we all make mistakes and it just granted us access. So another vulnerability we are going to see today is unsigned GWTs. Don't mind if I access your application with some unsigned GWTs. What is this vulnerability about? This vulnerability is about a login endpoint. The server accepted GWTs inside the headers again. But it never validated the signatures. So what does it mean? Is that the server is taking in the GWT token, it's decoding it, and it's granting you access or not, but without actually having a SIG and having a valid signature generation, checking, and a session cookie. So what can happen in these cases? What can happen in these cases is if you take the actual bearer token and you decode it using gwt.io or other services to decode the actual GWT tokens, then you can see how it is structured. And once you know how it's structured, then you can forge your own tokens. And if you forge your own token with a valid date and valid structure, then the application would likely give you access to these protected pages. So we can see here that when I did, I posted to some specific endpoint with a token that is not very real, there is no signature inside this token, we can see here at the end, then it just gives us access with a token value here that could be accessed and used later on other endpoints. Yeah, so what I initially tried, I noticed the applications used a token parameter in the login request. I tested with expired and tampered GWTs, which were still accepted. Eventually, I sent a GWT with no signature, and it let me log in. So this is also a common vulnerability that we can see on some applications when the authentication flow is not well written and not well secured. So how the payload was built, we created the GWT using the header and the payload, and this can just be done with gwt.io or any other tools like CyberChef or any other GWT parser that you know of. And then send the token into the login endpoint, and the application returned a session cookie giving full access to its protected area. So why did it happen and how does this work? The GWT are meant to be self-contained and tamper-proof thanks to the cryptographic signature. But when the server keeps verifying that signature, it accepts any payload, no matter how fake it is or how fake it looks. So the most important thing when testing GWT-related authentication flow is first trying to log in without a valid signature. And the second thing is also trying to send a null bearer token, which might sometimes give you access to the application, as we have seen in the previous bug. So it's a quite but deadly misstep. Just base 64 a fake user, skip the signature, and you're logging in like it's totally legit. Another authentication bypass, so I think you have seen the pattern here. We are looking into some different authentication bypasses vulnerability cases. Another authentication bypass that I have found recently is by sending a null password inside the login form. Yes, you've heard it right. And why this happened and how it happened is that we had this specific post request, which was a post request for a login endpoint. And if you send, for example, admin, it will not give you access because it's not valid credentials. However, when we send an empty password, then suddenly the application gives us access to the authenticated area, even though we don't have a valid account. So that's again another deadly mistake made by the developers, that they gave us access to the protected area by just sending in an empty password with a valid username. So we verified this in Burp Suite by stripping the password field entirely. The server responded with a full authenticated page, proving the password check simply didn't trigger at all. And so we have tried dummy password, SQL injection, trying to bypass the authentication flow and other things. Nothing worked, but once we send the login request again in Burp and remove the password value, we got a large 200 OK, which actually proved that we got access to the application without actually having any specific account that was needed to log in. And the payload was just used again in Burp Suite, and we can, of course, use again match and replace rule to automate that later on. Skipping password logic, login flow often check if credentials exist, but they always check if the fields are non-empty. This happens when devs assume the front-end will enforce from validation. But even here, front-end validation is not always, is never complete, because the actual patch has to be done on the back end and the front end to avoid any substantial issues. So it's a quite but deadly misstep. Just sorry, if the token structure looks okay, the backend trusts the payload. Another vulnerability we are going to cover is local files spilling the secret. We abuse the local file disclosure to access sensitive files like etc password, bash history, and file descriptor under proc self fd. This led to extracting domain and MS Graph API credential, Microsoft API credential. So we decoded a leaked graph token and found it had broad permission. So what happened is that we had a specific endpoint with a specific content, and once we sent a specific payload inside this parameter, this gives us access to the password file on the host, and then later on by doing further checks and checking proc self fd payload, then we got access to further secrets which granted us access to the Microsoft API graph token. So we used an SQL-based login access to an endpoint. We began fuzzing the path to test for file disclosure, and reading proc self fd and sh history revealed the graph token. So how the payload was built, we could use again Burp Suite or use curl or anything that can be used to send HTTP requests to the specific endpoint. Why and how this works? When applications read files based on user input, they are vulnerable if path validation isn't alright. Local file inclusions lets you reference system files like etc password or generic passes like proc self fd. So for the developers, we should always make sure to not let user enter some weird payload into the application, parsing it, and actually allowing file read access to something that is very sensitive on the application and inside the system. We go to the next vulnerability, which is a remote command execution, which we have found while doing some testing on an endpoint that looked like it was using curl to actually do some requests based on the user input. So what happens here is that we had this specific endpoint, which you can see here, and once we found what the pattern looked like, then we could build a payload. So the initial request just stops here at the 20, and all of this is what we have added to generate a payload from this to this. So in a service that used curl internally, we passed extra flags via input. Adding options like -x and k led the backend to fetch remote files. write output to disk, and drop a GSP shell into a web exposed directory. So what we have done here is that when we saw the initial feature, we started trying to send it some specific flags to see how it responds, and it dropped an error. And once it dropped an error, we could identify that it was using actually curl to make the request internally. So what happens here is that we were able to break out of the curl context that was happening in the backend and specifying our own payload that will eventually lead to remote command execution. So what we can see here inside this specific payload is that we are breaking here with the code, and then we are giving it -x, which is a curl flag to give post request, to give proxy, sorry, and we are setting it to my host, which contains the shell, and then we are giving the output to poc.txt, which will save actually the payload we gave it here. And so what happened is that it eventually gave us remote command execution access. Instances. So this worked because the input was never sanitized, and curl happily obeyed every extra instruction we snuck in. So we always have to try random things. Sometimes when you are testing an application, you think that some things might not work because it is not designed to work. But sometimes you try some random weird things, and you end up realizing that some things actually gives you some debug output that can further lead you to understanding how the feature was developed and how you can break it and do whatever you wish to do. Again, another remote command execution. We added a dash here, and what we can see here is the same application which is vulnerable to another remote command execution. This happened because we just discovered that at passing special curl flags like std error redirected the error logs to any file on disk. Using this, we wrote a malicious GSP file into the Tomcat web root, and we dropped a shell on that application. So we can see here the malicious payload which we used to send to the application, and this was sent inside the std error flag, which was eventually passed to the curl on the backend, and which actually executed the code on the backend for us and saved our shell code to the server which actually was vulnerable. And so we've then eventually visited the GSP endpoint with the CMG ID payload parameter, as this is what we have included inside our payload when we actually exploited the vulnerability. And then any setup that builds a system commands from user input without strict sanitation is a goldmine for exploitation. So once again, you have to always try some weird thing and see how the application actually interprets what we are sending it, so that we can see how it works. Another vulnerability here is proxy escaping, which was a server-side request forgery vulnerability that we found on some other big company. So what happened is that a reverse proxy path leaked access to internal apps by modifying the path like app main admin, who escaped the intended route and hit production admin, not internal, directly. This allowed us to browse and interact with internal-only admin panels. The server-side request forgery vector worked because the proxy followed internal redirects blindly. A small misconfig, big result. So what happened here is that host/API/main app/anything is pointing to internal application, And then when we send it another thing instead of anything, we send it admin, it's hitting internal-admin internally. So once we hit the /admin, which is on an internal host, it gives us access directly because it is blindly following the redirect payload inside internal parsing. And so the payload was built again by sending in the vulnerable payload using burp suite, and then DNS lookups revealed internal aliases being resolved server side and being following the redirect blindly. So in this case, we used a predictable escape path to reach internal domains through the public interface. It worked because the proxy trusted the rewritten internal host header. It became a web-based internal recon tool that is simple SSRF into full on-asset discovery. Another bypass we are going to see is again a payload bypass that uses extension-based. I have spoken about this multiple times, but I think that we should again bring it on because not very much of the people know how it works. So what happens here is that a website is protected, has protected its endpoint behind Microsoft login, but by appending this specific payload, so !.gpg to links, we bypass authentication completely. The application treated it like a static file and served it. This happens lots of the time when some applications has a reverse proxy that lets you access some specific endpoints based on the content that you are asking it to give it to you. But sometimes if you are able to trick the server to think that you are requesting a static file, then it will eventually give you access to what you are asking it to give you access to. So in this specific case, the path confusion was exploited using burp's rules to add GPG and GPG to every request. So suddenly, we had free reign over the application without logging in. So you can see here that we are inside a specific directory, and we are giving it the GPG payload to bypass the authentication. And the server responded with 200 OK, while it usually responded with 403, which means that we don't have access to this specific payload without any authentication check. And so we always try some different payload, but in this specific case, accessing the main endpoint, we got a redirect 302 on an SSO. And then once we send it the specific payload, we got a 200 OK, which actually gave us access to all the endpoints. Then once we find this kind of vulnerabilities, we can use burp suite match and replace rule to actually automatically replace the suffix of the endpoints and actually always add the specific bypass payload. So as we browse, it gives us access automatically without restricting any authentication. And so this trick turned every GET request into an unauthenticated read, effectively crawling the application as an internal user. The next bug we are seeing is again a SSRF with open redirect. So what happened here is that we chained an open redirect with server-side request forgery to fetch internal resources via public API. By pointing a redirect parameter to internal admin domains, we got full responses back through the proxy. This revealed everything from internal HTML pages to cloud metadata, and since it followed the redirects and served responses transparently, we didn't even need to exfiltrate, it came straight to us. So we can see here that we got a specific API request, and then we got here a parameter called link, and then the response of whatever we send it here inside the link. And so we can see that what happened here is that API public auth, and then we got the redirect here. And by pointing that to an internal domain, it actually followed the redirect and actually gave us access to that specific internal domain's content. and then we combined the SSRF with the public proxy into internal host. So this initially was not giving us any access to internal domains, but once we found the redirect payload, we actually was able to build a payload that actually gave us access to the internal domains. And so this setup became a data league machine, letting us explore the internal attack surface completely from the outside. The last vulnerability we are seeing is the full config control over a major dev forum. I think everyone knows the Apple developer forums here. We have found a vulnerability that could let us access actually pretty much everything on that specific domain. One single unauthenticated put request to a config endpoint allowed us to override any application-wide variable, CDN links, keyword filter, internal passes, all modifiable. So while doing bug bounty on Apple domains, I have found developers.apple.com, which is a developer forums, and by looking into some API requests, I found some API requests which looked like API/config, let's call it like this. And this specific config file returns some vars, variables, and I noticed that by giving it a put request instead of a get request, I could modify this configuration. So what happens here is that it let me modify the configuration of the Apple Apple developer forums, and I could point most of the links to my own domain. And so this actually gave us access to everything, because we then can see here communities.apple.com, and you can see here the link that I could change on the main index page. So if you can see here, youtube.com/embed callback, and with the XSS payload that I put in there. So everyone who was visiting developers.apple.com, the developer forums, or Apple Communities Forum, was actually going to be infected by my payload. And so I think that every day there are more than 50,000 people who visit Apple developer forums, but Apple swiftly responded to the vulnerability report and fixed the vulnerability very quickly. And I made sure every time, as I was trying and as I found the vulnerability on the system, I made sure to revert back to not cause any damage to Apple or to any users and harms to users. So what is funny here too is that I was getting callbacks from all Apple users who were visiting the Apple developer forums, because I had changed the links on the page to point to my own domain, and from there everyone who was visiting Apple developer forums was actually getting served content from my domain here, which actually made everyone send me some data, cookies, what he's sending requests to, and also IP addresses and lots of other secrets, because also Apple admins were also infected by this, because they were also using this specific software on some other hidden admin panels. And I got all the callbacks here on my own server. As you can see here, public/assets/favicon. This was sent by an iPhone of a user who was actually visiting my the Apple developer forums. What was also great is that it was caching the request. So once you visit one time, you have to wait a long time before it actually changes back to the original Apple content. So Apple swiftly fixed the vulnerability and secured what we have found on the system. So we browsed through the mobile application authentication flow. We found a signing with Apple, and then after that we have found that specific config endpoint, which let us have access to that specific config endpoint, which we modified and infected more than 20,000 people following the website. And this misconfiguration let attackers rewrite key parameters like CDN links, and admin controls, effectively hijacking the application behavior and enabling widespread exploitation. So basically it's like you own the domain, but you lose control of the domain because someone could modify some configuration on your domain, and then what you want to serve as a content is not what you are serving anymore because someone is controlling what is happening in the middle. And the takeaway is always to spot the logic gaps. Don't just scan, think like the developers, change the pain, small bugs, combined can lead to great bugs. And also you have to stay creative, stay ethical, bring assumptions, not the law, and always poke at the config application, misconfig, and others. So this is the end of the talk, and I'm happy to answer any questions anyone might have. Thank you so much. Yeah. Do we have a mic for questions?
Hi there.
Hey there.
Can you hear me?
Yes.
Hi, thank you for coming. I'm casual, but kind of top 55 on the Russian platform.
Yes.
Turned off. So I'm very happy about your
So I will move
presentation.
closer to see you. So, yeah.
I'm happy about your presentation, and I have a few questions.
Yeah.
About null authentication token bearer. Was it in only specific domain implementation or more wide?
About which vulnerability exactly? About which vulnerability are we speaking?
First, about bearer token authentication.
Oh yeah, the null? Yeah. Yeah, what's the question?
Was it about a specific implementation platform or more like...
So yeah, the program was on Buckroad, on Buckroad platform. So it's a public program.
If it were more wider problem, would you mind to actually take a time and make a boop extension to automatically send another request with your legitimate request with a null token to actually find if it's vulnerable?
Yes, of course we can always try a few things, but what happened here is that application was not parsing effectively what was being supplied to it, so it let us pass with a null bearer token. But if there is anything specific which we'll have to go in details, I will be happy to chat with you later on and take these specific things and tackle down what doubts you have.
Okay, and I have one small more. You were talking about all your great vulnerabilities, yes. And how much in percentage of those fun and just out of nowhere bypasses happens in wildlife? Yeah,
so very few people actually find these creative bugs because they stick to what they have learned, such as SQL injections, that's it, XSS, that's it. But very few people actually go for the creative part and thinking out the box. So I would always suggest to take this path and trying to find some things that are not common, because this is actually the beauty in hacking, because hacking is an art at the end of the day.
I meant, thank you for answer, but I meant how in percentage of those bypasses actually you had in overall?
So how much does it happen? So this is a very low percentage. I'm not going to say anything. Maybe we can say 5% of the times. But I have some specific checks I always do for this specific authentication bypasses. So I have maybe 15 different authentication bypass checks that I do on all kind of login endpoints. And if I have some luck, I might get in sometimes with one of that.
Thank you.
Thank you. Is there any other questions before we move in? I think that's it. Thank you so much, Russia, and I'm happy to be here. And question? Oh, that's it. Thank you so much. Goodbye.